Hello, welcome to Jet Mathematics. I remain your host, Milton Ebiwari John. Yesterday, I dropped a question on circle geometry, and I received so many shots that I should solve the problem. Okay, and so today I want to take our time to drop the solution to that problem. So, we have the diagram of the question here. We have been asked to look for angle A, angle B, angle C, angle D, and angle E. But remember, C is the center of the circle. Okay, then GW is a tangent, GS is a tangent, WX is also a tangent. So quickly, we're going to see how to solve that. Alright, so we have first we're going to get A. We're going to use the theorems from circle geometry to get our solution. Now the first is from the center of the circle, a line drawn to meet the tangency is perpendicular to the tangent. A line drawn from the center of the circle to the point of tangency is perpendicular to the tangent. So perpendicular means it's at right angle to the tangent. That means this line is at right angle to this tangent. So it's at right angle to this side, also right angle to this side. But since we are considering angle A, so this implies that angle A is 90 degree. So you are going to say angle A is equals to 90 degree. The theorem we applied again is a line drawn from the center of the circle to the point of tangency is at right angle to the tangent. Also, to get angle B, you also have a line drawn from the center of the circle to the point of tangency. A line drawn from the center of the circle to the point of tangency is perpendicular to the tangent. So, with the same theorem, angle B is equals to 90 degrees. Angle B is equal to 90 degrees from the same theorem. Okay, so we'll proceed to get angle C. So we can consider the quadrilateral. This is a quadrilateral now, a four-sided shape. So if we consider the quadrilateral GBCA, GBCA, we have that angle A plus angle B plus angle C plus 42 degrees will be equals to 360 degrees. That is sum of angles in a quadrilateral is equals to 360 degrees. The sum of angles in a quadrilateral is equals to 360 degrees. So this is the quadrilateral again, angle and quadrilateral GBCA. So we have angle A, C, B, and 42 to be the angles of this quadrilateral. So when you add up this, we already know angle A and B. So we have 90 degrees plus 90 degrees plus C degrees plus 42 degrees equals to 360 degrees. Okay, now we already know 90 plus 90 plus 42 is 222 degrees equals to 360 degrees. So solving this, you have C equals to 360 degrees minus 222 degrees. All right. Then finally, we are going to get or say that C degrees is equals to 138 degrees. All right. So that is quite simple to get. And then we'll proceed to get angle D. Angle D. So we say D is equal to, so we have another theorem in psychogeometry that says the angle at the center is twice the angle at the circumference. The angle at the center is equals to twice the angle at the circumference. That is to say that D is equals to 1/2 of C. 1/2 of C. So D degrees is equals to 1/2 times 138 degrees. That implies that D degrees is equals to 69 degrees. When you do the sum of, calculate 138 divided by 2, you get 69 degrees. So remember, the theorem we applied here is that angle at the center is twice the angle at the circumference. All right, this is where many persons could not calculate for angle E. Angle E was quite difficult for certain persons to calculate, and that is the purpose of this video. Now there's a theorem that says from the point of tangency to this point, and also from the point of tangency to this point, GA and GB are equal. GA is equals to GB. Okay? Also, looking at this, WS is also a tangent. That implies that from the point of tangency here to here will be equal to the point of tangency here to here. So that we'll have a triangle like this, X, D, A. So we can get this angle if here and here are equal. So we also say that AS will be equal to DS. AS equals to DX. Right? AX from the point of tangency to this point is also equal to the point of tangency to this point. Remember, we can construct a radius rather to this place. Okay, we can get a radius from here, from the center to this point of tangency. All right. So with this becomes a right angle triangle, an isosceles right angle triangle, and that will make this angle here 45 degrees, and this other one here 45 degrees. So this angle here is 45 degrees. That implies that the angle here is 45 degrees. Remember, from the center of the circle to the point of tangency is perpendicular to the tangent. That means the whole of this place is 90 degrees. So E degrees plus 45 degrees is equals to 90 degrees. The whole of this place is 90 degrees from the theorem that says that from the center of the circle to the point of tangency is perpendicular to the tangent. And so we have 90 degrees there. But remember, from this triangle, we have gotten here to be 45 degrees. So E plus 45 degrees equals to 90 degrees. So we have that E is equals to 90 degrees minus 45 degrees. So E becomes 45 degrees. So these are the solution. A is 90, B is 90 degrees, C is 138 degrees, D is 69 degrees, and E is 45 degrees. Please share, like, follow our page for more of lovely mathematics problems. See you. Bye.